In the last video, you saw the type comments for an arbitrary arity tree, and you saw how the mutual reference works in those type comments. Because of the two cycles, the tree can be arbitrarily wide at any point, and it can also be arbitrarily deep. You have now seen the most important part about arbitrary arity trees. In this video, we're going to do the templates, and there won't be any new template rules. The templates are just going to fall out from what we already know. So now I'm back in fsstarter.racket, and again, we've got the two types which have mutual recursion, and we're going to do the templates. And the interesting thing we're going to see about the templates is we already know how to do them. Just a reminder, when we have types that involve mutual recursion, what I do is put each type and interpretation together. So there's element and its interpretation, list of element and its interpretation. Then I put all the examples, and now I'm going to put all the templates together. And that's going to be much easier for us when we go to design the functions. And it also helps us see the mutual reference structure better. So here we go. There's going to be two templates because there's two mutually recursive types. So there's going to be that template and that template. And let's see. Notice I'm not putting the template rules used because you're not required to do that anymore, but I'll talk about them as we do it. This is a compound data, so there's all three selectors. And then I'm going to decorate that with the types of value that come back from the selector. So in the case of name, it's a string. In the case of data, it's an integer. And in the case of subs, it's a list of element. Now, list of element is a non-primitive type. It's a type that we defined. So the reference rule here says that we should wrap this selector into a call for fun for LOE. And I'm going to go ahead and do that like that. Now we're done with fun for element. For fun for LOE, well, let's see, this is a one of with two cases. So there's a cond with two cases. First case is atomic distinct empty. Second case is the second case, so we'll say else. Then it's a compound cons. First LOE, rest LOE. For a second, we'll just decorate those. Well, this is an element, and this is a list of element. The reference rule here says that we'll wrap this in fun for element. And the self-reference rule here says we'll go fun for LOE. So there we go. We've got the template for both types. And we didn't really need a new template rule. The reference rule and the self-reference rule just work to produce the right answer. In some sense, the only new rule for templating types involving mutual reference is to do both templates at the same time. That'll help you see the mutual recursion structure in the templates corresponding to the mutual reference structure in the types. And just to draw that out for you, let me switch again to this kind of figure that we've seen before, where I've got both the type comments and the templates, and you could see where there's a self-reference, there's a natural recursion. Where there's a mutual reference cycle, there's a natural mutual recursion. So fun for LOE calls fun for element, and fun for element calls fun for LOE. And in the next video, we'll see how that plays out as we're designing the functions.